Not a matter of if the Earth's magnetic field would disappear someday, it's a matter of when.
And what will happen to life if it does? Like a giant umbrella, Earth's magnetosphere shields us from the steady stream of cosmic radiation that fills our solar system. Exposure to this is deadly.
The magnetic field coming out from the Earth makes a big bubble around the Earth, the magnetosphere, that protects us from the most violent actions of the sun.
Many of the charged particles in the solar wind have enough energy so that they would represent a hazard to human beings if they made direct contact with the surface environment.
If you're in the path of this oncoming charged particles zipping out from the sun, if you're not inside some shielding, you're dead.
Without the magnetosphere, all life is vulnerable to these high-energy cosmic particles. They penetrate living tissue and cause severe damage to cells.
As the field becomes weaker and weaker, the effects of space radiation would be felt at lower and lower and progressively lower altitudes. So possibly one outcome of a reduced magnetic shield would be, through increased exposure to radiation, higher rates of cancer among populations.
Radiation causes damage at the most fundamental level. It mutates the blueprint of life, DNA. Earth's magnetosphere is our crucial defense. It's so fundamental to our evolution and continued existence that the race is on to understand why it's changing. Although scientists can peer millions of miles into space, they still can't see Earth's magnetic field. NASA scientist Dr. Mario Acuna's simple demonstration helps us to visualize its basic structure.
We can use a real bar magnet to visualize what the magnetic field of the Earth may look like. So we're going to put this under this piece of cardboard here, and now we're going to sprinkle slowly some iron filings.
In school we all play with iron filings, and we sprinkle them on a bar magnet, and we see these lines that form that go from the north to the south. And that in effect basically describes the rough geometry of the Earth's magnetic field.
So just as iron filings arrange themselves around the north and south poles of a bar magnet, the Earth's magnetic field spurts out like a fountain at the magnetic South Pole. It encircles the entire planet and streams back down into the Earth at the magnetic North Pole. Scientists believe it's generated 3,000 miles beneath our feet, deep within Earth's interior. From here, it throws out a vast magnetic cocoon that envelops the entire planet. This blocks out the solar wind. A constant barrage of superheated charged particles streaming from the sun at up to 1 million miles per hour. Professor Dan Lathrop of the University of Maryland has seen how powerful the solar wind can be.
Solar wind comes in and hits the bow shock on the magnetosphere and tends to just go around them, right? The whole thing's shaped kind of like a big tadpole. Most of the radiation then ends up streaming past the Earth. A little bit leaks in and hits the atmosphere near the poles.
In polar regions, where the magnetic field is weakest, auroras glow in the sky. These dazzling displays of colored lights form when solar particles slam into gases in our atmosphere, causing them to glow. The stronger the solar wind, the more dramatic the auroras. Although beautiful, they're a sign of the ferocious battle between our magnetosphere and the invading stream of solar radiation.
There's no magnetic field. Face-on radiation all across the planet.
But scientists have made an alarming discovery. Face-on radiation is hitting Earth. Out here in the Atlantic Ocean, just off the coast of Brazil, sits a region with a rapidly weakening magnetic field. It's known as the South Atlantic Anomaly. It's around 3 million square miles and growing. Every day, cosmic radiation reaches closer to Earth's surface. We don't fully understand the origin of this anomaly, but the consequences for life could be dire. NASA scientists monitor the anomaly's impact on technology.
The combination of the energetic particles found in the South Atlantic anomaly, as well as new particles being injected there by solar storms, have resulted in many total failures of communication spacecraft.
Satellites can be permanently damaged when they pass over the anomaly. Vital instruments on the billion-dollar Hubble Space Telescope have to be shut down for protection when it enters the area. As the magnetic field continues to weaken over the South Atlantic, radiation is reaching increasingly lower altitudes and could start to affect more than just technology. Professor Peter Olson believes air passengers will be the first at risk.
If you happen to take a long commercial jet flight, you would be flying through regions where the magnetic field is weak, and possibly at that altitude, increased radiation would impact the airplane.
This could disrupt radio communication, leaving pilots and passengers vulnerable. Scientists believe that the South Atlantic anomaly is a sign of a global decline in the magnetic field. Evidence of this comes from a surprising source. Dr. Mimi Hill uses pottery to uncover the secrets of Earth's magnetic past. Ancient pots tell us about our distant ancestors, but they also tell us how our magnetosphere has changed over thousands of years.
I'm very interested in ancient pottery because it's a really good recorder of what the Earth's magnetic field has done at the time when the pot was fired.
Clay contains tiny particles of a magnetic iron-based mineral called magnetite. Normally, these are randomly oriented, but when clay is fired at high temperatures, they start to move around.
All the little magnetic minerals will align up with the Earth's magnetic field. When it cools down, it's locked in.
As the clay cools and hardens, these minerals become remagnetized by the Earth's magnetic field, locking in a precise record of the strength of the field at that moment.
What we're doing is we're taking a tiny little core from an ancient pot and put the small core into our microwave arc intensity systems.
Hill measures the magnetite from an ancient pot. She uses this measurement to calculate the exact strength of Earth's magnetic field at the time the pot was fired.
And yes, we go on to the microwaving.
She compares this to samples taken from several pots over the last 400 years.
We know this is dated to about 1640, 1670, and can tell from the experiment that the magnetic field strength was stronger by about 10%.
Hill's research indicates that our magnetic protection is fading at an alarming rate. Professor Jeremy Bloxham believes that it may disappear 10 times sooner than expected.
If we could flip a switch and just turn off the Earth's magnetic field, it would take about 15,000 years to disappear. Based on the rate of decay of the field that we've seen over the last